Okay guys, welcome to section 3.1 for science, the second part of it. So the first part of it you guys have already done. You already defined the things that you needed to define, which was classical, modern science, Newton and Galileo, with the difference between scalar and vector, the difference between distance and displacement, and then vectors and resultants. Now, what you need to do today is you only have two things to define, and then the rest of it you need to be taking notes on how we do the examples and the practices together, because then you're going to do section 3.1 review. Okay, so you only need to define dynamics and mechanics in 3 sentences and define acceleration in 3 sentences, and then the rest of it is going to be asked in the review anyway. So let's go to practice 3.1b. What you need to understand for practice 3.1b is that we're going to be using speed equals distance over time. They're going to show you that in this lesson in physics, speed and velocity are different. Okay, if you go into Saxon math, speed and velocity are the same. Mathematically speaking, speed and velocity are the same, but when you get into physics, velocity is different because velocity has to do with direction, okay? So just like scalar and vector quantities, velocity is a vector quantity because it also takes into account your direction. So this one's not going to be distance over time, it's going to be displacement over time to find your velocity, okay? So here we go, let's look at 3.1b. Calculate the average speed of a car if it traveled 180 kilometers in 2 hours. So that one's easy. 180 kilometers is your distance and your time is 2 hours. So your answer is 90 kilometers per hour for number 1, okay? If you guys think that it would be more beneficial to you that you stop the video, do these practices, and then check it with me, you can do that. I just didn't want to leave you to do them all on your own for when you come to the ones that you're confused on. It's not going to make any sense for us not to explain them. Look at number 2. If an airliner travels 920 kilometers per hour for 2.5 hours, what is the distance traveled? So now you have the speed, right? But you're looking for the distance. You have the time, which is 2.5 hours. So what are you going to do? You're just going to solve for D. How are you going to do that? Well, 2.5 is dividing from the D, so the opposite of that is multiplying. So you're going to multiply it over here. 920 times 2.5. So your answer is 2,300 kilometers, because that's the unit that we started with. Okay? For number 3, what is the average speed of a race car in kilometers per hour if it travels completely around a 5-kilometer track in 1 minute? Okay, well, they want the speed in kilometers per hour. You're given that they can do 5 kilometers in 1 minute. Okay, so 1 minute, I would do it like this, you guys. You have the speed, you're looking for the speed, equals distance is 5 kilometers. To turn minutes into hours, I would just do it down here. 1 minute equals, we're going to put minute on the bottom, hour on the top, 61, right? So 1 divided by 60 is going to give you the decimal number for 1 minute out of an hour, which is 0.01666, repeating. And then divide 5 divided by that number is going to be 300 kilometers per hour. Okay? Because now you put that into hours instead of into minutes. Another way that you could do that, you guys, is think about it. If you can go 5 kilometers in 1 minute, how many minutes are an hour? 60. So 5 times 60? 300, okay? You could do it that way as well. You just have to, what they're doing is they're teaching you how to pay attention to your units, okay? Number 4, if a car travels 100 kilometers in 1 hour and another car travels 200 kilometers in 1.5 hours, what is its average speed for the entire trip? You might be tempted to say, okay, we need to take the speed of one, take the speed of another, then take the average of that, but no. All you have to do is remember total distance over total time. Your total distance is 100 kilometers plus 200 because that's how far the distance was traveled, and then 1 hour plus 1.5 hours. So that means you have 300 over 2.5, which is going to be 120. That's what they mean by average speed. Because if you look at it in the sentence right above practice 3.1, which you'll read later on, it says speed calculated over a distance as in the example below is the average speed. So using that formula will give you the average speed. It doesn't mean that they're consistently going that speed at every point in the trip. Sometimes you go up to 70, then go back to 60, then go up to then go down to 55, and then go up to 90. So your average speed doesn't mean that it's the speed that you're on the entire time. It's just over the whole time. That's the average that they went. Look at oh, that's all of them for practice 3.1b. So now let's go over to 3.1c and see if there's any examples before it. And there is, so we need to do example 3.1 first to get us ready for 3.1c. Okay, in 3.1c, the example is going to show you the difference between basically velocity and speed, but also what to do when one thing is moving with another thing. Ooh, I'm sorry, and there's one other thing that you have to write sentences about. You need to write sentences, 3 sentences on what are frames of reference, which I'm going to explain at the end of the video, so if you pay attention, then you're going to know it for your notes, okay? Frames of reference. But, okay, 3.1, look what it says. Consider the river just described. So here's a river. If you look at figure 3.8, you can see a canoe heading downstream, while the river is also going downstream. You have seen these kind of problems in math before. Let's say the river is going this way, but your boat is also going this way. The river is going 2 kilometers per hour, and your boat is going 5 kilometers per hour, right? Well, the current is going to be helping the boat, so really the current is going to be going 7 kilometers per hour because the current is going to be pushing the boat, okay? If the boat changes direction and it's working against the stream, then it's only going to be going 3 kilometers per hour because it's going to be going 5 itself, but it's going to be being pushed back 2. So it's going to be hurting the speed or the velocity of the boat, okay? However, what happens if the river is going south and the boat is trying to go east? But it can't just go east like this because it's going to be being pushed by the river, right? So if it's trying to go towards the east, but it's being pushed down, what direction is it actually going to be going? It's actually going to be going to the southeast, okay, to the southeast. Well, at what velocity? Well, you can easily find that if you recognize that this is a what? A right triangle. Okay, so that is what the example is going to show us, so you can see the real application for it. Then we can get ready for practice 3.1c. It says, consider the river just described, which flows south at 2 kilometers per hour. So we're just going to put that right here so we remember. Okay. What is the velocity of a canoe paddled upstream 5 kilometers per hour relative to the current? Okay, relative to the current. Well, this one, you guys, they're not telling you the time or anything like that, so you don't have to use the displacement over time. You just need to know the displacement, okay, the displacement. And it's the one that I just showed you. It's going 2 kilometers downstream the river, but your boat wants to go 5 kilometers upstream, so what are you going to do? It's -2 and a +5 downstream for the negative, because remember, velocity cares about direction. Upstream is positive, so you're going to have negative 2 plus 5 is a positive 3 kilometers per hour. Okay? That is the